Thank you very much. And so up next, we have quantum, which is obviously a technology that has a strong Danish heritage and legacy, but it's difficult to understand what are the opportunities out there in quantum as well. So we have Owen Lozman here from 55 North to run us through what is quantum, but what does it look like for the opportunities for the future of quantum itself. So I'll let Owen take it away now. Thank you.
Oh, thank you. Thank you, Oliver, and thank you for the opportunity to come and talk to you about a completely different topic. So I know we're a little bit far into the day. Everybody's had coffee, but probably not enough. So I'm going to start with a little warm-up to everybody. So can everybody just stand up for a sec? Is that all right? Just going to make sure you're awake, because if data centers were complicated, you would better strap yourselves in. So stay stood up if you've made an investment in AI or use AI. This is a good start. Stay stood up if you understand what a Van Neumann bottleneck is. I'm hoping that Meta from Microsoft still stood up, but so that kind of proves the point that, so Oliver asked me to explain what quantum is, and none of you understand what AI is. Okay, so I'm not going to explain what quantum is. I can happily do that offline, but I'm going to tell you what it does or what it can do, and then we can take it from there in terms of how it's going to disrupt things. So I'm managing partner of 55 North. We're a newly formed early stage venture fund in Copenhagen, and I'm going to explain to you a little bit about how quantum is going to be relevant in this area. So my previous job, I'm a scientist, a chemist. I was working in R&D, developing new materials for chips, so making smaller transistors. I then spent an awful lot of time building technologies and investing in companies that enabled all of the GPUs that we have now, so the technology that allowed us to do these large language models and deploy them at scale. So I was kind of, when Jeppe and the previous speakers were talking, I was kind of in the chip layer, but investing in the technologies to produce those chips, and that's what's led to this AI revolution that we have now. And everybody thinks about AI as being this huge disruptive technology, but it's took 70 years from the first computer to get to the point where we can really deploy these kind of models on systems at scale. So it's took a long time to get there. And I just want you to keep those few things in mind as we go through a little bit. So what is quantum computing? This is what computing looked like in 1900. This was the Babbage's first machine, developed in Manchester. It was a mechanical computer that added things up. It was probably easy to add things up on an abacus. This is kind of, okay, it's an AI image, but this is what computing looks like today. It's completely different, okay? This is what chemistry looked like in 1900. And this is what chemistry looks like today. Pretty much the same. This is what physics looked like in 1900, and apart from the cigar, it doesn't look too different now. So, you know, we have a lot of highly trained people pouring liquids and washing up, and we have them making devices and measuring them. And then this is a slide that my wife doesn't like. This is what biotech looked like in 1900, and this is what biotech looked like today. So after all of that pouring and washing up, we then take those chemicals, we make devices, we see what happens. We make displays, we make semiconductors, or we inject it into animals or people and see what happens, and then we make drugs and things like this, okay? Something a bit wrong with this. What's happened in the last 100 years? Why can't we do these things? The answer is, we can cover the entire planet with data centers, but we can't calculate things at the quantum mechanical level, and that's what quantum computing does. Quantum computing allows us to calculate these things so that we can turn all of this kind of experimentation into deterministic experiments, calculate stuff, go make it, make discoveries, deliver more sustainable materials, better batteries, better drugs for patients, and so on. This is just a kind of a small fraction of the promise that quantum offers. We're not there yet, but it's not too far away, and it's getting very close. And this is something that people like the Novo Nordisk Foundation have identified as a real opportunity. Clearly, they're very motivated, having had been a player in this. My old company, Merck, the German science technology company, also had a very interesting quantum, because you don't want to be the second pharma company to save $10 billion on your next drug pipeline, right? So there's a big opportunity for people, and nobody wants to get left behind. And that's why Novo Nordisk and IPO have invested in us and invested €1 billion over the last 5 years in the Danish quantum ecosystem. And it was actually one of the quite nice that the 3 talks previously have actually explained that as well. We have big international players like Microsoft. We have the Niels Bohr Institute. There's a long legacy. And it's not like AI where, okay, we can deliver data centers, we can get applications and we can build software, but we're not part of the trillion-dollar industry. We're not making the chips. We're not really benefiting in that fundamental layer. And in quantum, there's still an opportunity. There's a right to play and a right to win. And that's why we think it's exciting. So the market opportunity is really, we're kind of moving through this era. I like to go back to things that I understand, like semiconductors. We're going through this era of going from, the first vacuum tube-based computer, this is like an ion trap machine, to, the first transistor, first qubits, then to the integrated circuits, and Fairchild, and the original this is where VC came out of, actually. So, venture capital was born out of this integrated circuit. And then you see what happens, right? So those integrated circuits, you can make a clock radio, some mainframes, Pong. Anybody old enough to remember Pong? Then, mobile phones. This is like where all of this is driven by early stage, making transistors smaller, making more integrated circuits. Then we start to figure out how do we put these together better. And that's where things like system on chip, advanced packaging, we get the mobile phone, we get things like AR glasses, we get ASICs, GPUs, blockchain mining, and then that's led now to the AI revolution. And a lot of these technologies are also feeding into the quantum space too. So this is how we expect the market to develop. Firstly, we'll start with like simple things like clocks, and actually that's where quantum is starting. It's starting in very, very accurate clocks that will replace GPS. So you don't need to have a satellite. You can do this through a 5G network, and you can time things very accurately. To things like, I don't know if you'll have a Pong. I don't know if anybody's really run Doom on a quantum computer yet, but these kind of applications. So we're seeing how, and if you ask people in the 1950s, what can you do with computers, they would say adding up. And nobody could envisage large language models, even probably 5 years ago, 10 years ago, right? So big revolution happening, driven by these new architectures. And as I said, I invested a lot into Moore's law, advanced packaging, and then really what comes next. I'm a chemist, I want to simulate molecules. You can't do that. So the next wave, the next paradigm in computing comes from this new disruptive technology, which is quantum. Okay, so markets. We're not talking about, trillions of dollars of revenue just yet, but we're talking about markets that are going from pretty much nothing today, it's like $1 billion revenue, to sizable markets of tens to hundreds of billions within the next 10 years. These numbers are kind of taken from various market reports. I'm not sure I 100% believe them. But from an investor point of view, we're thinking about how do you get returns in this space, where are the real opportunities, and that's going to be evident on the next slide. So many big hyperscalers are already investing heavily, NVIDIA, Microsoft, as we heard earlier, Google, AWS, IBM. And this graph just shows like a technology roadmap. It shows you the kind of applications we expect to see as the technology develops. So we're still in the early stages of this, but that grows very quickly as the quantum computers improve and as the technology develops. Okay, this graph's gone a bit scary in the translation to Google, but mentioning hyperscalers. The point on this graph is that in the last year, there was 10 billion of capital invested privately into quantum companies. Over the entire history of quantum, there's been 18 billion. So last year, doubled the total amount of capital. Typically, these are financing 2 years worth of runway for a company. So that means over the next 2 years, we expect to see 10 billion of capital invested roughly falling down into the supply chain. And that's where the real opportunity we think lies in the short term, is in the supply chain. The other thing that we like to see, so there's money that's going to be deployed, and we think, how do we harvest that money? And then the next thing is, how do we get an exit? Where's the return coming from? Because it's all well and good investing in a company, but you want to know when you're going to get your money back. It's been a bit patchy over the years. There's been a few transactions. You may recognize some names. IonQ did a SPAC in 2021 at 2 billion. They were variously worth between 30, and I think about now 20 billion market cap, on a probably revenue about 100 million, something like this. So the multiples are not really normal. This year, we've already seen announced 12 billion of transactions. There's another 2 billion that we missed off there in an M&A that IonQ bought Fab. And there's going to be an IPO of Quantinuum. Their last post money was 10 billion. So that shows the public market interest, and there's going to be 23 billion at least of additional capital. One company on there, IQM, is a Nordic company that's Finnish. They actually have more machines sold than anybody else, and one of the highest revenue of any quantum company. They will SPAC in June for 1.8 billion. And that was the first investment that we made as a fund, just incidentally. Where is this money going? Like, as I said, there's, what does the value chain look like? We talked before about chips. We talked about the models. All of this is exactly the same picture that Jeppe showed in the original talk, of just slightly different. And we segment this in terms of maturity. If you look at the bottom there, this is the enabling technology, the manufacturing, the supply chain. This is maturing very quickly. There's an awful lot of capital going to get deployed in that area as these big companies start to mature their operations and start to think about, how do I make this at scale? How do I go from a lab experiment that shows like I can do this thing to something where I can actually scale it and make real systems that I can deploy? The full stack, this is the computer itself, the package, everything put together, the system. Initially, this was a race to see how many qubits could you make and what's the number of nines you could stick after it to do a 2-gate fidelity, if anybody's interested. Nowadays, it's about how many qubits can you put all together in a system. And the interesting thing, which I'll come to when I talk about Denmark, is that there's been an awful lot of capital deployed. The semiconductor industry has also developed a lot in the last few years. So we're now at the level of precision where we can put atoms, we can place materials with atomic resolution, which is what's needed for quantum. And we also have a huge infrastructure. In Finland, we have a fab that's been built. In Denmark, we have a foundry, which is secret, but it's under the car park at the BII in the Innovation District. It took me 6 months to get a ticket in there, down the fire escape at the back. And there's an awful lot of this technology which companies can now leverage. So if you're a full stack company, you don't have to go out and build everything yourself. You can use the supply chain that's been built around. You can use all of this great facilities that the governments have been investing in. And that means now you can make a company, like a company in Delft that we just invested in. With 2 million euros, they've got an 18 qubit chip. And within this year, they'll have a 100 qubit chip. It took IQM 10 years and 150 million to get to that same stage. This company is able to do that within a year. So the game has changed, and there's going to be an awful lot of opportunity in that full stack area to do very capital efficient investments and build companies that require less because they can leverage all that ecosystem that's being built. In the top, as in semiconductors, the real value comes from the applications. We're a little bit early. If anybody tells you that they can calculate this, that, or the other, they're probably lying, because it's still a long way away from what we call quantum utility. We're seeing early signs that you can improve drug discovery algorithms. You can improve things like sensing and things like physical AI, where you can train models using augmenting that with quantum data. But these are very early, and they're very, very niche. So there is revenue and there is value there, but it's not the level that you would say like an LLM does, where we can get 10 billion revenue in 2 weeks or whatever it is. But early stage opportunities, really outsized return potential. And as in semiconductors, we expect that's where ultimately the most value will be created. I think in semiconductors, if you discount what Jensen says and look at just the numbers from last year, they expect to be about $1 trillion in terms of revenue for the semiconductor industry this year. The digital economy and the internet and all the things that are built on top of it is like hundreds of trillions probably, right? So, and we expect the same to be true in quantum, but most of the opportunity at the minute is in that bottom layer in the enabling technology. Right, but too much data, right? So why Denmark? As I mentioned, we can't make semiconductors here, really. We used to be 35% market share in Europe of making semiconductors. We're now 8%. There's no way we can catch up. There's no way we can catch up with TSMC or the US. We can build the software, no doubt about that, and we can deploy useful applications, 100% agree. But that race is gone. But what we can do, we don't need to build like huge fabs to make quantum. We need to build the right things, the right technology in the right way. And Denmark has been like laser focused on this. UK, 15 different industrial priorities. Denmark's got like 2, 3. So that means the capital's been deployed very judiciously, very focused, and that's led to a lot of opportunity. And this is just the history of how we evolved as a fund. So it started off in 2021, and this is a lot of the investment from the foundation, building that enabling infrastructure, building the talent base, the technology. And now we have this huge talent pipeline, a lot of IP, a lot of infrastructure, and we were put together in order to try and leverage that ecosystem, leverage that, and to try and translate it into commercial value. So no pressure. Yeah, Denmark's got this, really, I think is really we get asked this question, why Denmark? And we didn't just come here because we had the capital here. We came here because it's the right place to be. It's kind of neutral in Europe. If you're in France, Germans don't like you. If you're in Germany, the French don't like you, and so on. Denmark's got a really good place. And a lot of the companies we speak to in the US are very keen to put assets and manufacturing and things in Denmark. Microsoft did that. We have this Atom computer coming here later this year, early next year, with the QNorth program. And the government is very supportive, and the foundation, etc. So it's a really good community. We're very happy being here, and we think there's an awful lot of value we can create as well. And I think with the manufacturing assets we have, there's a very strong right to play and a right to win in terms of building this ecosystem. We're doing that very closely with our Nordic colleagues as well in Finland and obviously across Europe, from the Netherlands, etc. Just to kind of exemplify this with some numbers, 50% of our deal flow comes from the US, 0% of our companies have gone through. But was one company that got through to an investment stage, but that is a company that's bringing their manufacturing to Denmark. US companies are typically very overpriced. And the value that we see, the value creation that we see is limited, and so we think there's a huge opportunity in Europe to fix that. We do need growth capital. So that's my quick foray into quantum. I'm happy to dig deeper. I'm also happy to talk about AI because I kind of knew a bit about that in the past. But I wanted to also highlight that we managed to convince the organisers of QTB to move the flagship quantum conference from Paris to Copenhagen this year, which is kind of a moment of pride for us as a fund, but also I think highlights how the global community sees Denmark's position in this ecosystem. It'll be a fun conference, yeah, I think if anybody's interested, it'd be great to see you there, and happy to teach you more in the meantime. And I can really explain what quantum computing is if anybody's actually interested, but I didn't want to bore you to death. So, thank you very much.